Let's finish lesson 0.3 talking about a new way to write your answer for inequalities. Typically, when you write your answer to either an absolute value inequality or just any inequality, you're using what's known as set builder notation. Answers like x is greater than 5 or x is greater than 2 but less than 10 is that type of model. A new way to write your solutions for inequalities is known as interval notation. And when you use interval notation, we don't use the greater than or less than type symbols. We use parentheses and brackets, and then the numbers that are our boundaries are the numbers that go inside those parentheses or brackets. You would use a parenthesis when a number has an inequality for the greater than or less than. You would use a bracket with a number if it's greater than or equal to or less than or equal to. Let's take a look at some combinations on the right-hand side and note what they look like as an interval solution and as their set notation solution. For that first example, we have a bracket around -3 and +4. To sketch the graph, if we create a number line, oops, I don't know why that's doing that shape, or that shade, I should say. We can create a number line. And you'd want numbers from -3 all the way over to 4. For our purposes, we're just going to draw -3 here and 4 here. Otherwise, it'll take us a really long time to get through this. Since there are boundaries on each side, what that would indicate is that -3 with that bracket is equal to, and +4 is also equal to. And there are brackets on each side, therefore our solution is everything in between. Now, set notation, we're going to use these brackets over here on the braces over here on the right for our solution. We're going to say, oh, I want a different color. Well, you don't have to say that, I guess, if you don't want to. I want red to match the set notation. X is our variable, or whatever variable you have in your equation. -3 is the boundary on the left, because we always write smallest to biggest, is less than or equal to x, which is less than or equal to +4. And that would be our set notation. Typically, we would write just the inequality for that. This is kind of the more formal approach to that solution set. Taking a look at that next example, now notice the boundary is again -3 and 4, but it doesn't equal -3. It gets infinitely close. So as interval notation, anytime it doesn't equal that boundary number, we use a parenthesis. So for -3, I'll put a parenthesis on the left. On the right, 4 has a less than or equal to between x and the 4. That will get the bracket. And then again, on your number line, to show that, at -3 and at 4, -3 would have an open circle this time. But I want it in blue. So -3 will have an open circle. 4 would still have a closed circle. And notice they're in between, so we would just connect them. All right, what I'd like you to do is just see if you can do the next one. I'm pretty sure you can. Graph the solution based on the interval notation, and then write the formal set notation. Press play when you're done, and we'll see if it went well. Let's see how you did. There's a bracket at -3 and a parenthesis at 4. That would indicate it can equal -3, but just gets infinitely close and has an open circle at 4. And then you see the set notation at the right. Notice we always write our small number on the left-hand side and then the bigger of the two numbers on the right-hand side. All right, let's finish this table with the rest of our interval notations, graphs, and set notations. I'm going to pause the video and fill this out. Go ahead and do the same thing, and then we'll be done. All right, here are the rest of the interval notations, graphs, and set notations. Notice for -3 and 4 with the parentheses, they're open circles on our graph. -3, infinity means the arrow just goes infinitely to the right. And notice we use infinity in our set notation as well for that more formal set notation. And then we have it in the other direction, and then we have -infinity to +infinity. That would be all real solutions, the entire number line. And then we wrote the inequality for set notation with less thans on both sides, or for both inequalities for that solution. So that's it for lesson 0.3.